Okay, so 5.4, some more examples here on exponential and logarithmic equations for you. So remember the little rule with this one, the bases. Can we make the bases the same? No, we can't. So to do this with rewriting it with logs, take whatever's up top, move it out to the front, take whatever's up top, move it out to the front with the logs there. Then I like to divide both sides by the smaller of the two logs. So I get log 3 divided by log 2, which is 1.5849. And then this is now nice and doesn't have decimals as well. Got to distribute that through, which is fine. So you get 1.5849625001x. Multiply that, you get 6.3398500003 equals 1 minus 3x. Just crazy decimals, combined your x's together. So I'm going to add 3, so it makes that 4.5 blah 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 plus 6 point blah 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 equals 1. Then I can minus that 6 point blah 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 onto the other side to put my numbers together. So I get 4 point blah 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 x equals negative 5 point blah blah blah. Just divide both sides by 4 point blah blah blah, and you end up getting about negative 1.164644204, and that's because I'm not rounding. You can round a little bit if you want, but this just makes it more exact. Same type of problem, can't make those the same, so I just bump those out in front. Then I'm going to divide both sides by the log of 2 because it's a smaller log. So that's nice, and I got a whole bunch of decimals here. Then I have to just distribute that through. So you still get a 2x minus 3 on this side. Now you get a 2.3-ish x minus a 4.6-ish. Okay, combine my x's together. I'm going to minus a 2x. So now I get 0.32 roughly x. And now I'm going to move this over to get my my numbers together. So now I get about 1.64 equals about 0.32x. I divide both sides by the 0.32, and we end up getting that x is about 5.1. Looking at this one, seeing this problem, if you wanted to, I can rewrite 8. I can rewrite that as 2 to the third, and then I really have, what's negative x equals 3, so I can already tell the answer is going to be negative 3. But if I didn't know that, this is like saying 8 to the first power. So you take whatever's up top and you bump it out in front. Take whatever's up top, bump it out in front. So really, I take the smaller log just like before and divide it. So I get negative x, and 1 times log 8 is just log 8. Log 8 divided by log 2 in your calculator is 3. Divide by negative 1, and you get sorry, that should be a negative 3 as your answer, not a positive 3. But that's because I saw I could rewrite it. If you don't see that, you can still do this method, is the point I'm getting at, and you'll still get the same answer. Over here, I see subtraction, that means division. So I can combine those together. But over here, I'm going to just push all the logs together before I start combining stuff. So all the logs are on one side. And just like that, when we were doing this in 5.3, I got a whole bunch of subtraction signs there. So look what happens if I don't put those in parentheses. I divide those first. Okay, so that's fine. But then I still have another subtraction sign, meaning I have to take this divided by that as well. So now I have a crazy fraction. Well, remember, you take the top and you can multiply it by the reciprocal of the bottom. So when you multiply by the reciprocal, that's really what you have there. So when I put that together on the bottom, x plus 2 times x minus 2, that's what you're looking at. Okay, so if I wanted to, I can FOIL the bottom to get x squared minus 4, because that's you end up getting a 2x and a negative 2x, which cancels out. Remember, when there is no base there, it's like saying base 10, so I can take this to the 10 and that to the 10, which when I do that, those cancel. So I get all of this equals 10 squared, which is 100. Then I can get rid of that fraction by multiplying both sides by an x squared minus 4. So I get x squared plus 4 equals 100 times x squared minus 4. I can take that through to get 100x squared minus 400, and now I can finally start combining terms to solve. I minus an x squared to get 99x squared. I can add 400 to this side to get 404. I can divide by 99 to get 404 over 99 and then square root both sides. And I should get plus or minus, because I square rooted at 2.02. So it's plus or minus 2.02. Just like the problem before, same idea, same concept, okay? Going to try to get all the logs on one side if I wanted to, or because I realize that they're all the same log, why don't I just push these two together? So when I do that, minus is like saying division, and since they're the same, I can just drop the logs, and I end up getting this. Then I can just cross multiply those two. 1 times 3x minus 10 is 3x minus 10. X times x minus 4 means I have to distribute that through. I'm getting x squared minus 4x equals 3x minus 10. And I can push everything on one side together. So minus a 3x, so I get negative 7x. I'm going to add 10 to both sides, so I get x squared minus 7x plus 10 equals 0. So can you think of two numbers that multiply to give you 10, that add to give you a negative 7? The correct answer is yes. Negative 2 and negative 5, because negative 2 plus negative 5 is negative 7. Negative 2 times negative 5 is 10. So I end up getting x minus 2 and x minus 5. So when I solve each of those, I get 2 and 5 as my answer, which will make each of those work. So x minus 2 does not work, or sorry, x equals 2 does not work, because when I plug it in, I'm getting negative numbers on that side. So you just have to check your answers sometimes to make sure that they both work. We'll finish up the examples here when I come back. I don't want to try to rush any of these.